Hi everyone, today I'll be presenting my implementation of a multi-class classification model using the IRIS dataset. I started by uploading the iris.csv file to my environment and reading it into a variable named iris. And I I checked the first five rows and mapped the species strings to integers, s- setosa to 0, versicolor to 1, uh, and virginica to 2. Then I verified the changes. Then I separated the features into X and the levels into Y. Then I used train test split with a random state of 1 to 3 and get the training and testing sets as requested. I verified that my training length is 120 and test length is 30. Then to prepare for the neural network, I converted the levels into one hot encoded values called one hot training levels and one hot test levels. And in 6a, I defined a sequential model with three dense layers. The first two hidden layers use 100 neurons and ReLU activation, while the final output layers uses 3 units with softmax. In question 6b, I complied the model using the RMS prop optimizer and categorical cross-entropy as my loss function because we are working with encoded categorical values. In question 7a, I trained this model for 20 epochs with a batch size of 10 and then evaluated it on the test set to report the final accuracy. In question for question 8, again I trained this model for 20 epochs with a batch size of 10 and then evaluated it on the test set to report the final accuracy. For question 9a, I created a smaller model with only 10 hidden units per layer to see how it compared. In, for question 9c and d, I feed this model for only 4 epochs. Comparing the two, the higher capacity model usually eh, achieves better accuracy, while this smaller version might show sign of using underfitting because of the limited neurons and training times. And question 10 AI, how the number of layers or hidden units could impact the accuracy of the model. So the answer is the number of layers and hidden units determine the model's capacity. Increasing them allows for more complex pattern recognizing but increases the risk of overfitting. Question 10a2, we don't always suffer from overfitting. If the model is too simple, we suffer from underfitting instead. Question 10A3. We detect overfitting by monitoring the gap between training accuracy and test accuracy. If training accuracy is much higher than test accuracy, the model has likely memorized the training data rather than learning general features. Question A4. We can reduce overfitting by simplifying the network architecture using techniques like dropout or implementing early stopping. In question 10b, finally, I experimented by changing parameters one at a time. Optimizer switching RMS prop to Adam often leads to faster convergence. Layer and units adding more layers can improve performance by make the model more computationally expensive. Epochs or batch size. Increasing the epochs gives the model more time to learn, while changing batch size impacts the stability of the training process. So this concludes my assignment presentation. I have demonstrated how to implement multi-class classification and how various hyperparameters impact the results. Thank you.